Hi everyone, welcome to Building Containers in the introduction to Singularity and Apptainer. In these episodes you will see how to build containers according to your requirements, and you'll see how we can download and assemble container from available images in repositories. So first, a little reminder that a container is a software with a context that you can run to execute your programs. This is different from the image that it can be seen as a template, a single image, for example, with Python 3.9 can be downloaded and can spawn multiple containers with different programs that are running in Python 3.9, maybe with different libraries that they are using. So normally we run a container and we prepare images to run these containers. So far we have been running from available public images, but that's not the only option. In many cases it is required to modify an image or even to create a new one from scratch. For such purposes, Singularity provides the command build, defined in the documentation as the Swiss Army knife of container creation. The usual workflow is to prepare and test a container in a build environment like your laptop, either with an interactive session or from a definition file, and then to deploy the container into a production environment for execution like your institutional cluster or the grid or the cloud. Interactive sessions are great to experiment and test your new container. If you want to distribute a container or use it in production, though, we recommend to build it from a definition file as described in the next episodes. This ensures the greatest possibility of reproducibility and transparency. So normally, to summarize, you start from maybe an existing image or from scratch definition. You can play in an interactive environment to test the different installation and make sure of what you want to obtain. And then you will build from a definition file your image that you want to distribute, share with other people, or deploy for your execution. So in this episode we'll see how to build a container in an interactive session. So first let's make sure that we have a Singularity. So we have Apptainer 104, perfect. And now let's continue with the build. While images contained in a CIF file are more compact and immutable objects, ideal for reproducibility, for building and testing images it's more convenient to use a sandbox, which can be easily modified. Practically, this is a directory that's created and that you can change. So let's use the Singularity command with build and the sandbox option. So to start, we want to create a Pythia container. So we'll start from a CentOS distribution. So CentOS, it's a Red Hat Enterprise Linux-based distribution, and we'll start from the images that are available on Docker Hub. So this command is downloading the images. The container name is my CentOS 7. It's a sandbox, so it will be a directory where we can modify the container, and has been initialized with the official Docker image for CentOS 7 on Docker Hub. Now to continue, we want to be able to write there. We use a shell. Use the option writable. And we will use also the fake root option. So I'm a regular user on this machine, not an administrator. So in order to be able to install program inside my container, I will use the fake root option, which allows me to be root inside the container. So inside the container, I'm root. So have present that fake root allows you to be root only inside the container. If you do any operation on the outside, you will still be doing as your regular user. Furthermore, if you were able to run this command without error, then it's okay. If you encounter an error while running Singularity with the option -- fake root, make sure that the program new ID map and new GID map are present. If not, let your site administrator know to add those programs which are necessary in order to run with the fake root option. So let's continue with installation. So we want to have Pythia 8 installed. So first we use the yum command to install all the dependencies. So yum is the command on CentOS and Red Hat Enterprise Linux based distribution to install packages. And in this case, I'm installing a group of packages that includes most of the development tools. So it's checking the servers, and we'll start soon downloading the packages. We'll ask for confirmation about the packages to install and about the signatures that are verifying the packages. And then the installation is continuing. So this installation will install almost everything, but not Python 3 that I have to install separately, because in CentOS 7 the default Python is still Python 2. So the next program that I want to install is Pythia. So here I have reported the instructions, but we want to check the Pythia website, because as you can see here, for example, the Pythia version is newer than the one that I used here, so we can use the latest version. Pythia is a program for the generation of high-energy physics collision events. For example, for the description of collisions at high energy between electrons, protons, photons, and heavy nuclei. It's a Monte Carlo simulator that generates physics events. So to install it, the installation of development tools completed. Now I'll proceed to install Python 3. And I confirm that. And after that, I will go for the Pythia installation and make a directory. Now we download Pythia. Its URL is the program to download. So on the website, I just saw that the latest one is 8.308. So I decided to install that one. Okay, it downloaded Pythia. Now I'm expanding the package. So if you get an error here, make sure that the URL that you use for the download is correct, because URL will fail silently and saving the 404 file in case you have a wrong URL. So I'm making a link now from the Pythia package to a generic Pythia 8 directory. This will be convenient later. Now Pythia is a C++ library to enable also Python. Its Python interface. I have to add the -- with Python include option during the configuration, and to point to the Python headers that I want to use. So I'm going to the directory, running configure. Okay, now I can build Pythia. The build process started, so this might take a few minutes depending on how quick, how powerful is your current machine that you are using to run Apptainer and to do this build. So I will actually suspend the video and resume it once the compilation completed, so you don't have to wait all the time. See you soon. Welcome back, everyone. So the compilation of Pythia completed, and with this part I'm done with the installation, so I can close the container. Now I'm back in my shell, and whenever I want to use the container, I can invoke with a shell command. So as you see now, I don't need any more the writable and the fake root commands, because this time I will not be writing and I will not be installing. So I'm exporting the Python path. I could even copy from here. And a little library path. So in order to be able to use Pythia, I need to modify both these environment variables. Then I start Python 3. I'm importing Pythia 8. And defining the Pythia object, which will print the splash screen for Pythia. So the installation was successful, and this concludes the first part. Please notice how I had to define the environment variable in order to use Pythia once I enter the container. In the next episode, you will see also how to add this environment definition inside into the container itself. Now the remaining of this episode is an exercise. In the exercise, we will be building a container with Python 3.9 and Uproot. Uproot is a Python library. It's a library for reading and writing root files in pure Python and NumPy. This is available in GitHub and as a pip package. So before starting the exercise myself, I'll be exiting here from Python and from Apptainer, and I will leave you a minute to pause the video so you can work on the exercise yourself before seeing the solution in the video. Okay, welcome back. I will now proceed to create the container to use Uproot in Python 3.9. Like before, I'll be using Singularity build and create a sandbox. This time I'll call the sandbox my Python, and I'll start from the Python 3.9 image that's available in Docker Hub. So Apptainer will be downloading all the images and building my local sandbox. Now I'll be using Singularity shell. And enter into the container. So you can notice that I didn't use neither -- writable nor -- fake root, because the installation for Uproot happens via pip. So these are user packages, and I can install them without being root. And they are installed in the home directory. So when Singularity or Apptainer start and they start the container, by default they mount your home directory and the temporary directory as writable directories, independently from the fact that the sandbox itself is writable or not. So the first step with pip is always to upgrade pip itself. Pip is the Python package installer. So it's downloading and installing the updates. Now I will install Uproot itself and awkward, that's a dependency. Now note how during the installation this happened in the directory nas home marcom local bin, and the same will happen also for the Uproot installation. So if I look at that directory, so if I exit from the container, and I look into this directory, I will see that there are site packages, and inside both Uproot, awkward, NumPy, and all the other dependencies are installed. Now printing home, you can see how nas home and marcom is actually my home directory. So these things are installed in my home directory. This is convenient for the sandbox for testing, but again, it's not a good way to create a portable package. So let's test if everything works. So to test if things work, I'll be printing the doc string of the uproot command. I'm starting the container, and I'll start Python and printing the uproot doc string. So everything is okay. So again, notice how we didn't use writable and fake root for the installation, but everything worked fine since pip installs user packages in subdirectory of your home directory. In addition, Singularity Apptainer, they install the home directory and TMP directory by default as read-only. So even if the sandbox itself is not writable, so both the home and TMP are installed as read-write. So this is why the sandbox is great to test and experiment locally, but should not be used for containers that will be shared and deployed. Manual changes and local directories are difficult to reproduce and to control. Once you are happy with the content, you should use the definition files described in the next episode. To summarize what we saw, the command build is the basic tool for the creation of containers. A sandbox is a writable directory where containers can be built interactively. Super users permission are required to build containers if you need to install packages. So you can use the fake root command in order to be super user inside into the container. And use interactive builds only for development and test. Use a definition file if you need to create production or publicly distributed containers. Thank you, everyone.